Today we'll take up the topic on mathematics for the class PUC 1 and in particular chapter 1 of sets. Sets are one of the fundamental concepts of mathematics. So sets are used to define relations and functions, and also it is used in other areas like geometry, trigonometry, probability, sequences, etc. And sets are a fundamental part of understanding the concepts in mathematics. So this was first found and developed by a German mathematician, Georg Cantor, during his understanding of the topic in trigonometrical series. So let us find out, what is this set and how we can define set. So basically a set can be defined as a collection of objects or a group of certain common things. So when we go into set, we will be able to define it as a well-defined collection of objects is called a set. And sets are denoted by capital letters A, B, C, and also X, Y, Z, etc. And the elements of a set are denoted by the lowercase letters or alphabets A, B, C, X, Y, Z, etc. So sets are denoted by capital letters A, B, C and so on, X, Y, Z, and its elements are denoted by the lowercase letters of the same alphabets like A, B, C, X, Y, Z, etc. So where we can note that if A is an element of a set A, then we say that A belongs to A. The phrase belongs to, denoted by the Greek symbol epsilon, and thus it is written as A belongs to A. So when we write or when we tell that an element A belongs to a set A, so here this capital A is the set and small or the lower case letter of this capital letter A is the element. So in order to write that the phrase belongs to, denoted by the Greek symbol epsilon, so this symbol is the Greek symbol, letter called as epsilon. So when we tell that the element A belongs to the set A, so we can write this in the form shown here, like A belongs to A and B does not belong to set A is written as B does not belong to A. So here you can write this epsilon and you can write a dash, so showing that this B does not belong to the set A. So here also we can give other examples, like odd natural numbers less than 10. So as I told you that set is a collection of numbers or objects or elements. So here when we tell that the odd natural numbers less than 10, so we can write this as 1, 3, 5, 7, 9, so which are less than 10, and it follows a rule that odd natural numbers, so these are all odd natural numbers. So we can clearly write this collection as 1, 3, 5, 7, 9. So this is an example of a set, which has a boundary or which has a limit, giving its group as odd natural numbers less than 10. So this collection of numbers, so belonging to this category, forms a set. So similarly we can take other examples like the rivers of India. So here we can write the rivers that are in India, like say Kaveri, Krishna, Godavari, so like that. So Ganga, Yamuna, all those names of the rivers we can write here. So here we can write this set as the names of the rivers of India. And similarly, so when we consider the example number 3, the vowels in the English alphabet, namely A, E, I, O, U. So what are the vowels in the English alphabet? So we know the vowels of the English alphabet. There are 5 vowels in the English alphabet. So that this forms a collection of a set of vowels. So namely A, E, I, O, U. And similarly the example 4, the 5 most renowned mathematicians of the world. So here we can write the names of the renowned mathematicians. So that is 5 most renowned mathematicians of the world. Say like George Cantor, he was the one who tried and developed the set. And various kinds of triangles. So this also forms a set. So what are the different kinds of triangles? Say like acute angle triangle, absolute or obtuse angle triangle, or right angle triangle, or scalene triangle. So all these forms are various kinds of triangles. So this also can become one of the examples for set. And similarly the prime factors of 210, so namely 2, 3, 5 and 7. So this will become a set, or this will form a set, so belonging to the prime factors of 210. And the other example, the solution of the equation x square minus 5x plus 6, so namely 2 and 3. So when we try to solve this equation for x, so x can take the value 2 and 3. So the solution of this equation can become a set. So like this we can go on giving examples to define set. So these are generally used. So sets are, as I told you, sets are generally used to define functions and relations. Example in geometry, in trigonometry, in sequences. So where we have to define relations and functions. So now we'll try to go and understand how to represent a set. So here there are 2 ways of representing a set. So one way is called as the roster form or the tabular form or listing method, and the second is the set builder form or the rule method. So these are the 2 ways in which we can represent a set. So let us understand, so what is the meaning of the first one, so called as the roster form or the tabular form or the listing method. So here we have a particular way of writing. So that is, in this roster form we list all the elements of the set within curly braces. So these are the curly braces and separate them by commas. So these are the curly braces, and we can separate the elements by means of commas. So we can write some elements. So like elements we can write and we can separate it by commas. So this is one form of representation called as the roster form. So similarly the second one, so called as the set builder form or the rule method. So in a set builder form we list the property or the properties satisfied by all the elements of the set. So here all the elements that are present in the set have to satisfy a particular property, or we list the numbers or so on in the particular braces, so which satisfy a particular property or properties, and all these elements that are present in this set have to satisfy this particular property. So let us see, so what is this set builder form and roster form? Now after having defined what is a roster form and what is a set builder form, so we will take one example of a roster form, the set of all even positive integers less than 7. So here we can write this in the form of brackets, as we have seen how to represent a set in the roster form by two braces and the elements separated by commas. So therefore this can be written as in the roster form as equal to and in the braces 2, 4, 6. So because these are the even positive integers which are less than 7. So this is the rule that we are following to write this particular set in the roster form. So here you have to note that the order in which the elements are listed are immaterial while writing this set in the roster form. So the order in which we write may be immaterial. So we can write in any way. For example, we may also write this as 2, 6, 4, or in any order we will be able to write. So but an element is not repeated in the roster form, but the element should not be repeated in this roster form. So this is the rule that we have to follow in order to write the elements in a roster form. And going for the example of a set builder form, as we have seen that there is a certain property and all the elements in this set should satisfy that particular property. So example, if we take this as set V equal to X, where X is vowel in English alphabet. So here, as we have taken this example in the previous form, you have seen that. So here you have seen that the vowels in the English alphabet, namely A, E, I, O, U. So if you take these vowels in the English alphabet, so in the roster form we will be able to write what are the vowels in the English alphabet. So but in the set builder form, so it is a property wherein all the elements belonging to the set are all the vowels. And similarly in the second case where the set A is equal to X, where X is a natural number, where X is less than and greater, so where this X lies between 1 and 5. So here we can write this set of natural numbers, say where this value of X so lies in between 1 and 5, say like 2, 3, 4. So all these are X values, so in which X is a natural number and it lies between 1 and 5. So when we write this in the set builder form, so this is the way of representing this in a set builder form. So whereas when we write the actual values of X, so then that will become a roster form. So we will try to understand, and so by considering more examples, so that we will be conversant with these two ways of representing sets, say like how to represent set in a roster form and how to represent a set in a set builder form. So if you take a simple example, say write the solution set of the equation x square plus x minus 2 equal to 0 in the roster form. So here the given equation is x square plus x minus 2 equal to 0, and this can be written as x square plus 2x minus x minus 2. So finding the factors for this, so we come to know that x plus 2 into x minus 1 equal to 0. So therefore we can say that the x has two values where x equal to minus 2 or x equal to 1. Therefore, the solution for the equation is x equal to minus 2 and x equal to 1. Therefore, the solution set for the equation x square plus x minus 2 equal to 0 is set A. So that is, in braces we can write minus 2 comma 1 in the roster form. So here it is clearly defined that the solution set of the equation x square plus x minus 2 equal to 0 in the roster form. So that what we have to write. So therefore, so this can be written as in the form of a set where minus 2 and 1 are the solutions, and which can be written as a set A in braces minus 2 so comma 1. So this is the representation in the roster form. And similarly, to understand, so we can take one more example, say to write the set x where x is a positive integer and x square less than 40 in the roster form. So when we consider this example, so the solution for this in the roster form can be written as set A equal to 1, 2, 3, 4, 5, 6. So here the set has to follow. So this particular rule where x square should be less than 40. So now how to write this? So how we got this? So values of A, of set A as 1, 2, 3, 4, 5, 6. So can be explained like this. Say 1 square equal to 1, so less than 40. 2 square equal to 4, so which is also less than 40. Like similarly 3 square equal to 9, less than 40. 4 square equal to 16, so again it is less than 40. 5 square equal to 25, so which is again less than 40. 6 square is equal to 36, so which is again less than 40. So but the higher number, say if we take 7 square, so it is equal to 49 and which is not less than 40.